Now let's look at Boolean operators. These operators are used to make decisions in programs. For example, you might check whether a student both submitted their homework and scored well on the exam, or determine if a customer qualifies for free shipping if they spent more than $50 or are a premium member. Mastering Boolean operators is essential because they control the flow of a program and allow us to handle complex decision-making. How are Boolean operators used in decision-making? The AND operator requires that both conditions are true. For example, a student must submit homework and score above 70 to pass. Both conditions must hold true for the result to be true. The OR operator requires that at least one condition is true. For example, a customer qualifies for free shipping if they spend more than $50 or if they are a premium member. In this case, satisfying either condition is enough. By combining conditions with these operators, programs can make smarter and more flexible decisions that reflect real-world rules. Let's look at the AND Boolean operator. The AND operator is a logical operator that performs a conjunction. This means both conditions must be true in order for the whole expression to be true. Looking at the truth table, if both operand 1 and operand 2 are true, then the result is true. If either one is false, the result is false. If both are false, the result is also false. So AND only gives us true in one case, when both conditions are true. The OR operator is a logical operator that performs a disjunction. This means the result will be true if at least one of the conditions is true. Looking at the truth table, if both operand 1 and operand 2 are true, the result is true. If operand 1 is true and operand 2 is false, the result is still true. If operand 1 is false and operand 2 is true, the result is still true. The only case where the result is false is when both operand 1 and operand 2 are false. The NOT operator is a logical operator that performs negation. It simply flips the truth value. If the condition is true, NOT makes it false. If the condition is false, NOT makes it true. Short-circuiting occurs when Python stops evaluating a Boolean expression as soon as the truth value has already been determined. In other words, if the outcome of the expression is clear from the first condition, Python will not continue checking the remaining conditions. This behavior improves efficiency and can also prevent unnecessary operations from being executed. But before we look at the example of short-circuiting, let's consider this simple program. We have a dividend set to 64 and a divisor set to 0. The program then tries to divide the dividend by the divisor. Dividing by 0 is not defined in mathematics, and as you can see here, it will cause a runtime error in Python. Now let's look at this example. The condition here is written as if true and dividend divided by divisor. Since this is true in something, Python must still evaluate the second part to determine the final result. The second part attempts dividend/divisor, which is division by 0, so the program still causes a runtime error. With the OR operator, Python evaluates from left to right. Since the first condition is already true, Python doesn't need to check the second part at all. The entire expression must be true no matter what. This is an example of short-circuiting in action. The second part, dividend/divisor, is never executed, so the program will not crash. To summarize, short-circuiting is when Python stops evaluating a Boolean expression as soon as the outcome is already determined. With AND, if the first condition is false, Python skips the rest because the whole expression must be false. With OR, if the first condition is true, Python skips the rest because the whole expression must be true. This behavior makes programs more efficient. The match statement is a modern way to handle branching in Python programs. It was added in Python 3.10, released on October 4, 2021, so it's still a relatively new feature. If you've seen other programming languages like C, Java, or JavaScript, they have a switch statement. Python's match works in a similar way, but it is more powerful. Unlike switch, which usually only compares values, Python's match can check patterns, unpack data structures, and even apply conditions called guards. That makes it much more flexible for writing clean and readable decision-making code. This is the basic syntax of the match statement in Python. We start with match, followed by an expression that we want to evaluate. Then we write one or more case blocks. Each case represents a possible value or pattern the expression might match. If the expression matches X, the code block under case X will run. If it matches Y, the code under case Y runs, and so on for each case. This example shows how the match statement works in practice. The variable value is set to 2. We then use a match statement to check its value. If value equals 1, the program prints 1. If value equals 2, the program prints 2. If value equals 3, the program prints 3. If none of the cases match, the wildcard case underscore is used, and the program prints something else. In this case, since value is 2, the program will print 2. The important thing here is that only the first matching case is executed, and the underscore acts like a default case to catch anything that doesn't match. This example shows how the match statement can be used to build a simple command menu. The variable command is set to the string add. Then the program checks the value using match. If the command is add, it prints adding task. If the command is remove, it prints removing task. If the command is list, it prints listing tasks. If the command does not match any of these, the wildcard case underscore runs and prints unknown command. In this case, since the command is add, the program will print adding task. This is a practical use case of match, and it's much cleaner than writing multiple if and elif statements. Thank you. This presentation was prepared by June Lee with the assistance of AI technology.